That's good. Okay, everyone, let's kick off. Thank you for joining today's seminar. Before I introduce our speaker today, I will just mention some of the other talks coming up in this Biodiversity in Nature series for this term. And next week we've got Mike at the same time, all the lectures. Next week we've got Mike Moorcroft from Natural England on climate change and nature recovery from global thinking to local action, describing Natural England's program of activities around nature recovery. The week after we have Gareth Williams on learning from some of the world's most remote coral reefs. A week after we've got our own Rob Salguero Gomez on quantifying and predicting resilience. And the week after, Rachel Carmenta on connected conservation, rethinking conservation for a telecoupled world. And then Tom Harwood on the future for nature, quantitative perspectives on land and biodiversity under global change. And I'll also mention one other event that's just got into the diary that isn't on the program. On July the 11th, we've got a debate between George Monbiot and Alan Savory on holistic grazing, which will be at the Natural History Museum. So bring your popcorn for that debate. If any of you followed bits of it on Twitter. Okay, so it gives me great pleasure to welcome Tim as our speaker today. Tim is Professor of Invasion Biology at UCL in London, and has a range of work on invasion biology, particularly a lot of work on birds in particular. And before that, he was at the Institute of Zoology as director, and I had a lifetime full of administration before moving in that period. So it's wonderful to have you here, and I'm particularly enthused to find out what the wonders are inside your jewel box. Thank you.
Oh, thank you very much. I assume the microphone's working, and yeah,
that'll just
people can hear me.
So you can shoot.
Okay. So yeah, thank you very much for inviting me to talk to you today. So I'm actually really excited because this book has been 3 years in the making. So it's almost exactly 3 years that sort of set out on the process, which is coming to fruition in about 3 weeks when this is published in the UK. This I got my hands on yesterday. This is the first copy of this I've seen. And I'm really excited to talk to you about this. You are the first people that I've talked to about the book. So that's the plus. You're also the first people who have the opportunity to get your hands on copies of this anywhere in the UK. The flip side, and I apologize for this, is I've not talked about the book before. So this is the first time I've talked about it, and I have no idea how this is going to go. I've basically spent the last 3 months agonizing as to how I can possibly really cleverly summarize a 90,000 word book in a 45-minute talk. And I think the real breakthrough came last week when I realized that I couldn't. And therefore, I just wasn't even going to try. So I stopped stressing at that point. And instead, what I'm going to do is just going to, I'm going to try and do 3 things, if this works. Let's see. Well, great start. Also not a great start. Sorry, it was working. Now it's not working. Okay.
So you try that.
Okay, brilliant. Thank you. Yeah, so basically the talk's going to be in 3 parts. I'm just going to give you some background as to how I sort of came to be writing a book. Then I'm going to try and take you through some of the aims, what I'm trying to do with the book itself, and then just give you a very rapid overview of the structure so you can see the sorts of the scope of it and what I'm trying to cover and what I'm trying to do with it. But if you actually want to know all the details, then I'm afraid there's no alternative than to get yourself a copy. So let's start with the genesis. So actually, the real starting point for this book goes back around about 7 or 8 years when I came to UCL and I got handed the ecology field course to teach. So for many years, we took students to this place. This is Kindrogan. It's an old Victorian country house in just south of the Cairngorms in Scotland. Queen Victoria stayed there. It's now or it was then a Field Studies Council field centre. So we would take students to this place every year, and we would introduce them to ecological sampling of different sorts. So we would take them to look, we would do the bird censusing, we would do some aquatic invertebrate censusing, we would do some pitfall trapping, and we would use this as a mechanism to introduce them to biodiversity that the students didn't know, but then quantify that in different ways as a way to start understanding how ecologists quantify the diversity of the natural world around them. But for me, the exciting part of this trip was that Kindrogan had a moth trap. So it actually had a bespoke little shed it had built by the side of the River Ardle, and in this was a Robinson MV moth trap. And there must be, like deep in my past, a memory of having seen people moth trapping at Woodchester Park on the University of Manchester field course I did as an undergraduate in the 1980s, but I had no memory of that. And so going to Kindrogan and asking them to run the moth trap every year was just like the high point of my year. So the first time that we ran it, I was just absolutely astounded. So, my role in the field course is to take students and show them diversity that they don't know about. And then we ran the moth trap, and suddenly there was all this diversity of insects that I had no idea were there. And the moth trap is just a remarkable thing. It's a box with a light on top. There's that cliched thing of moths. They're attracted to light. They get dazzled, they fall into the box, and you go and open up the box in the morning. And it's just full of these incredible insect wonders, these little jewels of things that sit in the trap. And this just had me completely hooked. And so every year, I couldn't wait till we went up to Kindrogan and we could run the moth trap and, have a couple of days just, basking in the glory of these amazing insects. And then, of course, what would happen is that after a week up there, I get on the train, go back to London. Essentially, that's a 6-hour journey through the degradation of the UK habitat, from some nice habitat or nicer habitat up in the Highlands through eventually till you get to the city of London and home. And it was that was always a bit depressing. It's nice to be back with the family, but at the same time, your senses come alive when you're out in the wilds. It's quiet, there's just nature. And then you're back in London and everything has to be dialed back down because of the noise and the pollution and all the people around you. And then after I've been sort of doing this for about 3 years, I sort of got back to London, and it's like, do you know what? I could probably get my own moth trap. I'm not particularly the fastest thinker. It took me about 3 years to realize that, maybe I could do this times other than when I went to Kindrogan. But I live in the London Borough of Camden. It's not the most biodiversity rich place, was my assumption. This is our outside space. It's our roof terrace. It's about 2 meters by 4 meters, about 20 feet up, and a flat in Camden. It's not always the most hospitable place. Would we get even any moths there? London is full of light sources. Putting a light out to try and catch moths, maybe it's just a pointless exercise. But nevertheless, it just happened to be my birthday about a month after I got back. So I said to my wife, could I possibly get a moth trap for my birthday? And so she bought me this moth trap. Obviously, this is not a view from my roof terrace. And I set it out and started to see if anything would come. So that first night was just, I sort of went to bed and sort of barely sleep. What's going to be appearing in the moth trap the next morning? Would anything appear? And so, the fact that I went out the next morning and opened it up and there were 82 moths of 28 species had just materialized out of the London air into this moth trap on my roof terrace was just this sort of further marvel. So this is a different trap, one of the ones I sort of borrow from work, but this is on my roof terrace in the summer last year on one of those very hot nights. and it's not particularly clear, but there's Jersey tiger that Charles was just mentioning to me, ribbon wave, there's tree lichen beauty here somewhere. Where's that? Oh, tree lichen beauty there. Anyways, about a dozen species of moth in the trap. And this particular night, which was utterly crazy, about 500 moths came to the trap on my roof terrace just on that one night. Now, most of them were horse chestnut leaf miners, tiny little things, but nevertheless, it's just incredible what's there. And yeah, I mean, just amazingly beautiful creatures just appear in London. So who knew that in Camden, you know, there were these incredible lime hawk moths or elephant hawk moths. It's waved umber that I caught just last week. I mean, just, you know, stunning diversity and really beautiful. And over the last 5 years or so, you know, I don't trap every night, obviously, but probably around 300 species of moth have come to my roof terrace in London. And for comparison, you know, the UK has about 75 butterfly species across the whole UK. So it's just remarkable what is there. And this just completely hooked me. So it went from sort of an annual highlight to just becoming an all-consuming obsession. You know, it got me and many people through those COVID lockdowns. It was a real steep increase in the number of records and people submitting moth records to their national schemes during that first lockdown, because when people couldn't get out to wildlife, getting wildlife to come to you was, you know, something that was possible. And yeah, now basically anytime I go anywhere, it's always predicated on, is there somewhere I can run the moth trap? You know, is it somewhere that's, you know, potentially interesting moths? And so, yeah, the moth trap goes on holiday with me everywhere now. And, you know, trying to just, you know, it gets you to some, you know, fantastic places. This is a Heartland point in North Devon. But it's just, yeah, it just completely hooked me. And so by sort of a happy accident, in that first COVID lockdown, so I guess April or May 2020, I had a random contact from this woman called Claire Conrad, and she said, "Hi, I'm a book agent. I've read some of your stuff online. I think you can write. Would you be interested in writing a book?" And you know, something popular science. And I said, well, it's funny because I've always thought about wanting to write a popular science book on ecology, but you know, I've sort of, you know, yeah, oh sorry, you know, I've sort of sketched out notes a few times, but I've just never been able to see how to make it work. And so Claire said, well, why don't you write it about the moth trap? And as soon as she said that, it's just like, oh, I can immediately see how this is going to all hang together. So I ended up working with Will at the same agents, and so I wrote a proposal. They asked for essentially a sample of your writing. So I wrote the introduction. I wrote then a table of contents, and then Will sort of went to various publishers and said, "Would you be interested in writing this book? In publishing this book?" And that's how I ended up working with Jenny Lord, who's my editor at Weidenfeld and Nicholson, and Rebecca Bright, who's my American editor at Island Press. And essentially, with you know, the help of all of these people, they navigated me through the process of writing a book. So, what am I trying to do with this book? So there are many, you know, really fantastic popular science books that are about certain groups of organisms or about certain systems. And what I really wanted to do was trying to write a book that explained to the general public how ecological scientists think about the natural world, how they think about how diversity is generated and maintained, and all those processes that essentially go up to make the contents of a moth trap. You know, that diversity of forms and numbers of species and the abundances, you know, how does that all work? How does nature, what are the rules that sort of mean that that first night in Camden, I caught 82 moths of 28 species rather than 50 species or 100 or 200 moths or whatever. And so, you know, ecology is the scientific study of the abundance and distribution of organisms. So, you know, this is the science that you need to be able to understand, to work out how nature is you know, is creating this diversity and giving that to you in a moth trap. And so that's what I set out to do. But actually, it's a pretty daunting task being an ecologist, and this is something else I really wanted to try and convey. So, you know, ecologists, we often have physics envy. So, you know, physicists are amazing at, you know, they can put, here's our planet, they can, you know, fire a rocket off that and put a robot on another planet or on an asteroid that's moving through space, you know, across hundreds of thousands of kilometers over years, and it's just remarkable. And we often envy that because, you know, that sort of abilities and predictive ability in ecology is often, you know, we pale it by comparison. But I would argue that actually physicists have it really easy. You know, so in physics, I mean, what is it? There's 4 fundamental forces, 17 fundamental particles, 118 elements. You know, that's chicken feed, it's peanuts. You know, if only we had such, you know, limited things to have to worry about. You know, in ecology, so, you know, we start out, we classify things as species. So we've got, you know, we've got around about 1.5 million named species so far. Each one of those is different. It lives its life in a different way. Even if we're just thinking about moths, I mean, that's still about 1 in 10 of those species. So 140,000 species of these fantastic Lepidoptera. And in fact, it's really 160,000 species because we tend to distinguish between moths and butterflies, but butterflies are really just a, you know, a little group of moths that have taken to flying by day and therefore are a bit more showy and get better publicity. But that's what we know. I mean, you know, we're trying to understand this system where actually we don't know most of what is even out there. So, you know, there's huge variation in estimates of how many species there really are. You know, maybe 3 million, maybe 100 million, 8 million rather is probably a, you know, a realistic ballpark estimate for how many eukaryotes there are. As for prokaryotes, it's kind of interesting when you go and look for estimates. Sometimes they're remarkably low. You can find people estimating that, you know, there's maybe as few as 10,000 prokaryote species, or maybe it's actually, you know, 1 trillion. Is that 1 trillion? It is. Yeah, you know, but that really comes down to the fact that we, you know, have very little clue as to what really is a species for a prokaryote. But that's just the species. I know each of those species is made up of individuals. You know, we have, you know, a couple of hundred breeding bird species in the UK, but those birds, those breeding birds, probably about 161 million individuals across those 200 odd breeding species. And each one of those individuals is different from every other individual, even within the same species. You know, Britain's fairly small country, it's fairly impoverished, probably about 83 billion rather, birds worldwide, we reckon. And this is, you know, this is birds. This is a group where we can even have a hope of maybe estimating how many individuals there are. You know, when you go and look for estimates of how many insects there are, so this is the Smithsonian Bug Info website. It suggests there's 10 quintillion, hang on, yeah, is that right? Yeah, 10 quintillion individual insects. I don't know what that means. Is that adult insects? Is that, I presume that's alive at any given moment? Who knows? But anyway, you know, if you believe that, and maybe it's a ballpark, you know, that's 100 million insects for every breeding bird in the world. Does that seem about right? Then, you know, our prokaryotes are bacteria, maybe 1 billion bacteria in a gram of soil. I mean, it's, you know, it's crazy numbers. And then viruses, you know, you go to the virus websites and they suggest, oh, there's maybe 10 to the 31 viruses in the world at any given time, I assume. And they say that if you line all those viruses end to end, that would span 100 million light years, which seems, I know, yeah, I did the calculation, and actually, yeah, you know, when you find out how many meters a light year is, the fact that you've got 31 zeros there, you know, that is actually, that's feasible. I've done the calculation more than once, and it's like, yeah, I've never believed it, but it could be the case. So that's, you know, that's a lot of stuff to try and have to understand. And of course, all those species, all those individuals, they're all interacting all the time. You know, if we just again focus on moths, like in the UK, we've got 2,500 species of moth in the UK, roughly. You know, there's more potential communities of moths than there are atoms in the universe. And that's just in terms of UK moths. How many combinations of those 2,500 species could potentially live together? It's insane. And of course, you know, every second, that whole picture changes. Individuals are born, they die, they move, they interact. And, you know, that's been going on throughout the whole history of life, you know, 126 quadrillion seconds, you know, this constant change. So it's incredibly difficult what ecologists have to do, and kind of trying to understand, you know, how all these systems work. Yeah, maybe it's not a surprise that we don't have hard laws like the physicists do, and we just maybe have some rules as to how things might work. So ecologists, you know, it's a really tough job that we have to do to try and understand this. And where do we even begin? Well, of course, what we do is we begin by breaking the question down into smaller segments. And then ideally what we do is we understand those small segments, and then we slowly piece them back together into more and more complex wholes, until maybe by the end we'll have some sort of general understanding for how the natural world works. And that's kind of what I've tried to do with this. Sorry, I'll just check the time. And of course, you know, we rely on data, you know, we rely on samples of the natural world. We can never hope to, you know, we don't know even how many species there are, all the species. We can never hope to understand everything. So we have to work with samples. And so one way that we can sample the natural world is the moth trap. This gives us a little insight into the diversity that's out there. And so this is a quote from the introduction, which is essentially, you know, by paying proper attention to these tiny creatures, the moths that appear like magic out of the darkness into a moth trap, and by piecing together all of those little snapshots of the world, we can really start to understand how the natural world works, and, you know, the rules that drive all of this incredible diversity with which we share a planet. So that's basically the background to the book, what I'm trying to do with it. So how I've done that then is over a series of chapters. So there's nine data chapters, or maybe 8 data chapters and a conclusion. Each one of those is inspired by a species of moth that I pulled out of my trap, or not, in the case of the stout dart. So this is a book that, you know, I frequently say it's not a book about moths, really. It's a book about how the world works, but it's illuminated by moths and it's illustrated by moths. So what I've tried to do is I've tried to, you know, take examples from the ecological literature as when, you know, problems have been addressed with moths, and how that has then informed our understanding of the world. So all I will do for the rest of the talk then is just briefly, very briefly, just whip through the chapters. That's just because from the titles, it's not always obvious what they're about. But if we start with that first chapter, so this is a moth that I pulled out of my trap on that first morning on the Camden roof terrace. So lepidoptera, I mean, it means, you know, scale wing or tiled wing, because these creatures have these beautiful scales across their wings, and the colors of those scales give them these amazing patterns. What you can see on a moth like this is that it's clearly the worse for wear. So all of those, or most of the scales, have been sloughed off. You sort of have these sort of canvas-like sheets sort of under all those scales, which are pretty ugly. That's sort of the hard chitinous exoskeleton of the insect. And of course, when you're identifying things mainly on the patterns on their wings, when you get something like this, you know, you're on a bit of a hiding to nothing. But this one was actually sort of identifiable in part because of these sort of fantastic antennae that it's got. So this is actually a species called the gypsy moth. So this is a male. So this is another one from the roof terrace in Camden. It's got these amazing antennae. The females don't fly. The male, they release pheromones, and the males follow the pheromone trails to the females using these pheromone sensors on their heads. It's a stunning moth. but it's a species that I think for some really good reasons illustrates life's superpower. And this is the fact that, you know, life can reproduce itself. Life can make more of itself. And this is the fundamental starting point for all of our understanding of ecology, I think, and also all of our understanding of evolution. So, you know, at the very simplest, you know, probably the first organisms that appeared on the planet, you know, maybe they reproduced by simply sort of, you know, they were single cells, they reproduced by dividing. But this is actually a really powerful process, you know, so you start with one, the next time step generation, there's 2, the next one, there's 4. Just this simple doubling very quickly can give you very large numbers. So one of my colleagues at UCL, David Colquhoun, he has this example of a pipe that starts leaking in Wembley Stadium. So here's Wembley Stadium. There's a pipe that starts leaking at midnight on the 1st of January. So in the first minute, sort of 1 drop comes out of the pipe. The second minute, 2 drops come out of the pipe. The third minute, 4 drops come out of the pipe. But the number of drops after each minute doubles. And he says, how long will it take for Wembley Stadium to overflow with water? Anyone want to hazard a guess?
3/4 an hour. 2 hours. 10 minutes.
Ooh, dramatic. It's actually somewhere between you, you're spanning it, 44 minutes. So, I mean, he actually says, you know, if the pipe started leaking when the cup final kicked off, the stadium would overflow before half time. And this is the power of doubling. It's just, you know, it's just incredible how quickly things can increase. And of course, that's just something that splits in 2. You've got something like a gypsy moth, you know, that will lay maybe 200 eggs, you know, so potentially that's increasing much more than just doubling with each generation. And kind of why this why this species is relevant is because of this man. So this is Leopold Trouvelot. The writer Maria Popova says he remains best known for his exquisite astronomical illustrations. As an ecologist, I would argue with that. So he was something of a science polymath. He was French. He went to the US in the 19th century. One of the things he was interested in was silk production. So moths are producers of silk. It's a very valuable commodity. And he was trying to see if there were other species than the classic silk moth that could be used for commercial silk production. And he took to the US a sample of gypsy moths. And he took them to his house in Myrtle Street, Medford in Massachusetts. And around about 1868 or 1869, some of the moths accidentally got out of the window of his house into the garden. It's not recorded whether they were eggs or caterpillars or what they were, but anyway, he kind of realized that this was could be a problem, and he apparently informed the authorities that this had happened, but exactly what he said and who he informed has sort of been lost in the mists of time. But this is relevant because about 20 years later, so Trouvelot had sort of moved on by this point and sold his house to someone else. About 20 years later, people really started to notice that there were a lot of caterpillars in this particular part of the world. So there's actually lots of documentary recording of people went to interview the residents about these caterpillars. And these are the caterpillars of the gypsy moth. So here's Mrs. Follansby. The walks, trees and fences in my yard and the sides of the house were covered with caterpillars. I used to sweep them off with a broom and burn them with kerosene. And in half an hour, they would be just as bad as ever. There were literally pecks of them. There was not a leaf on my trees. So a peck is about 9 litres, a volume of about 9 litres. Then we've got Mrs. Snowdon. I've seen the end of Mrs. Spinney's house so black with caterpillars that you could have hardly told what colour the paint was. And then Mrs. Ransom. In the evening, we could hear the caterpillars eating in the trees. It sounded like the clipping of scissors. And so these gypsy moths, they suddenly realized after about 20 years that this population had exploded and it was stripping all of the vegetation, all of the trees across this town of Medford. And so the authorities leapt into action to try and deal with this. So they sprayed bits of the town with Paris green. It's an incredibly toxic chemical. It does kill insects. It also kills rats and pretty much anything else. Here's some people up in the trees trying to strip the gypsy moth eggs off the trees. So these they lay their eggs in sort of big plaques. big yellow plaques. But of course, by the time they got onto this, it was too late to do anything about it. And the gypsy moth now occupies more than 1 million square kilometers of northeast North America, in the US and Canada. It's not always very abundant in the environment, but it has outbreak years. And in those outbreak years, like 1990, for example, it defoliated about 2.8 million hectares of forest. So it just shows you life's superpower. I mean, we don't know how many insects got out of Leopold Trouvelot's window, but it's probably no more than a handful or two. And yet within 20 years, they had taken over this town, and 100 years on, they have just spread massively across that part of the world. And of course, all populations have the capacity to do this. Just as long as any population is producing more offspring, each individual in that population is producing more than one offspring on average, then that population is going to grow, and it has the potential to grow out of control. And of course, I was writing this as the COVID pandemic was raging, and I'm sure you remember these situations. Well, there's not only a few cases. Why do we need to worry about it? Why are we panicking so much when hardly anyone's got this virus? And the reason is that graph, because when the virus is when each individual with the virus is infecting more than one other individual, that population of infected individuals is going to grow very quickly. So basically, all of ecology, all of life is based on this universal innate desire for organisms to live beyond their means. We're no exception to that. But of course, what happens is, populations don't grow forever. They do get reined in. Something happens that means that the population, doesn't grow forever. And of course, the reason, as we know, because we're ecologists, we're not economists, is that we live on a finite planet. So eventually resources run out, eventually things get under control. So then moving on from sort of growth of populations and how, this superpower of life, reproduction, can really cause populations to explode. Then we come on to the things that actually start to keep them in check. So the importance of food. I illustrate this, I start off by illustrating this with the footman moth. So these are a group of moths that are named for the liveried coats that servants in the households of the rich in this country used to wear. But this is a species that caterpillars feed on lichen. Following the Clean Air Act in the 70s that the Clean Air Act came in, lichen has resurged in this country, and the footman caterpillars have got lots more food, and the footman populations are growing really quite dramatically across the UK, it shows the importance of food. But of course, once you have things consuming food, then inevitably food is a limited resource, resources run out, and it means that species will butt up against each other. So any species that is using the same resource as another species is likely to end up in competition with that species. And I illustrate that with some of the work that's been done in part in Oxford and Wytham Woods with the winter moth and the green oak tortrix. Of course, it's not only what moths eat or what organisms eat that limits their populations, it's what eats them. And that's the next chapter, illustrated with the oak egger. So this is one of those occasions where an ecologist makes a prediction and it comes true, and I was very proud of this, because before I'd caught oak eggers, I predicted I was going to catch them, and I predicted them on the basis of this particular species, which I'm sure Charles will be familiar with. This is an Enicospilus inflexus. It's a specialist parasitoid of oak eggers. So the moth trap doesn't only attract moths, it attracts other insects as well. And so finding this species in the trap led me to believe that there must be oak eggers in the area, because this is an obligate parasitoid of that species. And sure enough, a couple of weeks later, I caught my first ever oak eggers. So yeah, it's hardly quantum electrodynamics, but any prediction that comes true for an ecologist is good. And it's, yeah, the moth trap, it does attract a lot of predators as well. So this was this one fantastic occasion where I just caught this box tree moth in London, and I looked up and a wasp had come barreling in, to the trap, and it dived onto this box tree moth, and then they proceeded to wrestle each other off the table and onto the floor. I've got a whole sequence of photographs that I don't really have time to show, but you could see the wasp stabbing the box tree with its sting, paralyzing it, and then it essentially snipped off the wings, it snipped off the legs. This wasp was just covered with scales. It was just this glittery, this sort of disco wasp because of all these wonderful box tree moth scales all over it. But then this thing just picked up this package of of protein that had left with all the appendages snipped off, and then it flew away. Parasitoids, incidentally, sort of some present company accepted, a hugely underestimated part of our global diversity. And I think there's around about 100,000 species of parasitoid described, but there are some sort of reasonable studies that would suggest that there may be on average one specialist parasitoid for every other species of insect on the planet, which would mean that essentially every other species of insect is a parasitoid, and would also mean that they're hugely underdescribed. So the fact that the moth trap attracts predators, it's always a source of stress for a moth trapper, because you're attracting these insects in, you love them, they're beautiful, you just want to see them. But the birds very quickly get to know that a moth trap means food. So this is in Devon, this particular great tit. I go to Devon fairly regularly to trap in the holidays. Normally, as soon as I get down there and set the trap out, the birds are sitting there. There's a pair of robins, and I don't know if they're just like very long-lived robins, or they're passing this information down to their offspring. But pretty much as soon as I set the moth trap up, they're sort of sitting there waiting for the moths to come for their dinner. And the great tits and the pied wagtails are the same. And of course, Charles Darwin was very clear-eyed about this. We forget that all of this life that we see is essentially destroying other life, and that's what all animal life is based on, is consumption and destruction. So something like the great tit, I get stressed when it grabs one of the moths from the trap. But if you do the maths, if you've got a pair of great tits feeding their young in the breeding season, and you work out how many great tits and blue tits there are across the whole of the UK, and you work out how many caterpillars they're bringing in, because they're basically bringing in a caterpillar every minute throughout, a 16 or 18-hour day at the height of the breeding season, you can work out there's probably more than 2 billion caterpillars are being, fed to great tits and blue tits on any given day in the breeding season. So, don't like to see moths being eaten, but in the grand scheme of things, there's a lot of destruction of insects that these birds are doing. So the first 3 chapters are really about births and deaths and the trade-off, and if births exceed deaths, then populations grow very quickly. So what is it that then brings deaths up and births down so that populations don't grow out of control? What species do between birth and death then sort of leads to essentially the diversity of forms that we see in the structure of species, which is sort of reflected in their life histories. So here we have a couple of species. Here we have a couple of, keep wandering away from the camera, sorry guys. Here we have a couple of species that essentially, they're the same kind of form, the same shape. This is a goat moth. This is about the size of my thumb. This is a codling moth. If you've ever bitten an apple and there's half a caterpillar in that apple, you've probably sort of just predated a codling moth. So something like this will whip through its life history very quickly. It will grow as quickly as it can. It will get out of its apple and into the ground to pupate as quickly as it can. The goat moth, its caterpillars live in the heartwood of trees. And a goat moth, it can take 5 years for this thing to go from egg to adult. And because the caterpillars are safely protected in the heartwood of trees, it can take its time and it can grow big. And in mammals, we tend to think of, big as the trade-off for being able to reproduce a lot, but it's kind of a different thing in insects, because, something that grows like this can actually produce a lot of eggs. So the trade-offs are a little bit different. But what species do between those 2 bookends of life, being born and dying, then affects the sort of forms that we see in a moth trap. Then up to that point, I've kind of been thinking largely about populations, so maybe sort of interactions between 2 or 3 species. But of course, populations don't live in isolation, they live in communities. We tend to think of communities in terms of similar sorts of taxonomic groups of species. So we'll think of a moth community, for example. And of course, as I said earlier, there's an enormous variety of potential sets of species that could live together. And then as we move up a level of complexity from population ecology to community ecology, then we have to start to try and understand what it is that determines how many species can live together in the numbers that they do and which species can coexist in communities. So I kind of illustrate this through a couple of, through the species of moth, the uncertain, which I catch quite regularly on the roof terrace in London. What I don't catch very often is this species. This is a rustic. So I think the uncertain is called the uncertain because it's so similar to the rustic that mothers weren't really sure whether this was really the uncertain or not. But it's kind of an interesting question. So, sometimes there are some areas where I catch only uncertain. There are other areas where the rustic occurs, but often you get both of them together. And actually, sometimes you get this third species as well. Like in London, this is a vines rustic, which is just, spreading across the UK, probably on the back of climate change. So here are 3 species that are pretty much identical to me. I mean, I really struggle to tell them apart. If you look at their life histories, they do pretty much exactly the same thing, and yet they can live together in the same area, apparently in the same community. So, what's going on? How do we understand how communities work? I was always brought up to think, well, species can only live together if they do something completely different to anything else that's in the community. So they have their own sort of way of life that is different from everything else. But, species like this, I think question that, and, maybe actually, just being equally good at something allows you to persist in a community just through the actions of chance. I don't know. Anyway, I think the uncertain is a good title for a chapter on community ecology, because we're trying to understand a situation where we don't know how many species there are, we don't know how many individuals there are, we don't know which species there are, because you never have a full view of the community, and yet we're still trying to work out how that all fits together. What the community does highlight, though, is an aspect of ecology that I kind of ignored up to this point, to keep it simple, which is that organisms move around. In fact, I would say that everything has to move. If things don't move, then essentially, populations are not going to grow, they're not going to spread. Even things that we think of as static, like trees, trees have parts of their life cycle which are specifically dedicated to moving them away from their parent to exploit new opportunities. And what the study of communities, leads to the realization of is that, communities are maintained, populations are maintained by the movement of individuals in from other places. So migration is fundamentally important, and it's actually a topic that is just really beautifully illustrated by moths. So and particularly this species, this is a silver Y. You can probably see why it's got its name, this lovely mark on its wing. This one was on my roof terrace yesterday morning. And this is kind of a remarkable moth, really. So who remembers the 2016 European Football Nations Cup final between France and Portugal? No, it was a pretty, it was a pretty dull game. It was 1-0 to Portugal, I think, after extra time. But here's Portugal's star player, Cristiano Ronaldo. In about the 20th minute, he got injured, and while he was waiting for the stretcher to come and take him off, this moth came and landed on his forehead. And actually, if you watch that game, what it was, at least for me, was mainly memorable for was the fact that this was at the Stade de France. They'd left the lights on over the previous night, and essentially what they'd got in the stadium was the world's biggest moth trap. And so if you watch highlights of that football match, I mean, there are moths everywhere. I mean, on the nets, on the corner flags, on the players. I mean, it's just insane. And almost all of them are this silver Y moth, which is just one of the most incredible migratory species that you can imagine. So, it maybe weighs like 100 milligrams, or maybe 1/10 of a gram, something like that. It's difficult to be sure about that. But this is a species that, migrates across Europe. So if it's got a wind behind it, it can cruise at 40 to 50 kilometers an hour. So, you know, something that weighs 1/10 of a gram. So, you know, it can potentially cover more than 600 kilometers in a night. And this is a species that moves up from the continent into the UK in summer to exploit the sort of the burst of resources here. It goes through generation here, and then the offspring will go back across the channel. So it's not a migrant in the same way as birds are, but it's a hugely migratory species. And it's estimated that maybe 700 million might cross the channel in any given year. And some years there are particularly big influxes across the whole country, and then the fields are sort of alive with the sound of silver whys. I think there's a lot out this year, actually. At least my sources outside London tell me that. But they're not alone. So actually there's lots of insects are migratory. Some are even more remarkable, I think, than the silver why. I mean, this is a diamondback moth. It's about the size of a grain of rice, but that will fly across the North Sea in large numbers. You know, that appeared in my moth trap could have set off from the continent the night before. And the studies using upward facing radar in the south of England have suggested that, you know, there's perhaps as many as, you know, 3.3 trillion individual insects sort of annually sort of migrating across in the airspace above our heads. So, you know, we think of birds, you know, particularly at this time of year as the summer migrants come in, we think of birds as, you know, as archetypal migrants and indicators of summer, but there's this incredible, largely unseen migration of insects going on over our heads. And it's been estimated that that's more than 3,000 tons of insect biomass sort of passing across the south of England and Wales in any given summer. Most of those are little things, you know, aphids and the like, but large insects like the silver why, perhaps as many as 225 tons. And for comparison, you know, all those summer migrant songbirds that come in to the UK in any given year, we somewhere over 400 tons of those. So those birds are a small fraction of the biomass that's sort of up there migrating. So what the study of communities and the realization that species coming in from elsewhere is important for the maintenance of populations and the maintenance of communities leads us to realize is that we actually need to understand what it is that generates that wider diversity. And this is where we get into the study of diversification, which is the birth and death of species, speciation and extinction. To understand diversification properly, we need to know what species are there, where they live, so that we can start to understand patterns in richness and what might drive that. And so for the most part, we can only really study this with the megafauna, with birds and mammals, because those are the species that we know well enough to really understand these processes. But I would argue that hawk moths like this poplar hawk moth, they're megafauna too. And in fact, we have a pretty good idea of the diversity, at least of hawk moths across the old world that we can use to study some of the questions as to why some areas have more species than others. And that's what I talk about in this chapter. Then kind of finally, I can't really finish up, you know, no treatise on ecology these days can really finish without mentioning this new issue that has happened to the world in the last few hundred to 1,000 years. The fact that all of these ecological processes that I've discussed in the previous chapters are now being infiltrated and co-opted by one particular species, and obviously that's us. So we are bringing in species that you know, have never naturally occurred in areas like the box tree moths that I catch regularly in London, and also we are driving species to extinction like the stout dart that I will never now catch in the UK because it's disappeared from this country altogether. So this chapter really focuses on, you know, the impacts that humans are having and how our action through ecological processes is increasing consumption, increasing competition, elevating mortality, changing life histories, changing the structure of communities, even changing patterns of diversification. We are inserting ourselves into all of these fundamental ecological processes. And in terms of UK moths, the situation is not great. Roughly third decline since 1970 in the overall UK moth population, and probably a lot more since the 1930s, although we have a lot fewer data further back we go. So there's been a lot of talk about, Insectageddon and the declines of insect populations, a lot of debate about how real that is, but British moths, pretty good data that would suggest that that is a real thing. And then finally, I just want to finish up with a little chapter where I basically make the point that, as H.G. Wells said, it's being forced on our reluctant attention that the species Homo sapiens is no privileged exception to the general conditions that determine the destinies of living species. So we are as dependent on ecological systems and ecological processes. These rules apply just as much to us as to any other species. And we need to bear that very much in mind. And I finish up with this sort of squitty little micromoth, the Acer sober, something I catch in London, but when I started catching in 2016, this species didn't even exist. So it's a recent split. It was only described in 2017. That comes to my moth trap in London. And kind of the point I really want to make is that, all of us have species like this out there, the unknowns that are in the environment. We tend to think of the tropics as the great area for discovery, and it undoubtedly is. We know far less about the tropics than we do about the latitudes that we live in. But even where we are, even in the London borough of Camden, there are species out there that we don't really know and understand, and it would be to our benefit, I think, if we paid attention to things like that. Thank you very much.
Thank you. Terrific. Wonderful. Wonderful. So, we could open up the question now.
Thanks, Tim. That was great. It struck me as you were talking about the moths you catch in Camden, how many you wouldn't have caught. How many species, if you were doing it 20 years ago, the Jersey tiger, the gypsy moth, the tree-lichen beauty, and the vines rustic. And you mentioned for vines rustic that you thought it was climate change. Do you think all of them can be explained by climate change, or do you think there are other processes, maybe deterministic, maybe just stochastic at work?
Yeah, I mean, it would seem to me that in general, this sort of southern spread of species across the UK, it would, and given that also we're seeing the recession of, species, other species to the north, that would suggest to me that there probably is a climate element to that. And certainly there have been some studies, or I know at least one study in review that would suggest that. I mean, obviously it's not the only thing that's going on. And clearly, I suspect that there's this issue about the fact that, we've got a lot of alien plants, which is potentially facilitating the spread of species. Obviously, there's lots of aliens that are being moved in as well, although that's a slightly different question. But it would seem to me that given how things are spreading, climate change would seem to be at least a significant contributing factor.
This may be pushing it a bit, but the one you might have caught 20 years ago is the garden tiger, which is now pretty. Yeah. Do you think that the garden tiger going and the Jersey tiger coming in, there might be any link?
I don't know, because we've also got scarlet tiger, haven't we?
That's true.
Yeah, spreading in another direction, which hasn't yet reached Camden, but obviously I'm, got my fingers crossed for that one. Yeah, I suspect that's. I mean, obviously there's. Lots of other ways in which we're messing up the environment. And I suspect that garden tiger may have something to do with that. It's kind of interesting that garden tiger is decreasing and Jersey tiger is on the increase. I will say that where I trap in Devon, actually, the locals there were like, oh, we've Jersey tiger. This is the only place in the UK that we've got Jersey tiger, which, 20 or 30 years ago, was the case. It's like, but in London. But what's really interesting about moths, and actually you see it, is just in that sort of fine detail, how you can see populations change, species spreading, communities changing. And it's in a way that, it's the kind of thing we study in birds, and obviously you can study it in birds, but I just find in moths, it's just a much more fine-grained sort of set of changes that you see. I catch things in London that Ben doesn't yet get in Oxford, but, he will eventually. I just have to make the most of it for now.
Any more questions, gentlemen?
What was your most exciting moth capture and why?
Well, yeah, writing anything down is always dangerous because, you know, you think, oh, this is as good as it's going to get, and then something comes along to beat that. So like my favorite thing, you know, and the reason why that chapter on the goat is about the goat, because I also, you know, goat is an acronym for greatest of all time. And I just think, you know, that is a remarkable moth. I mean, it's gorgeous, it's huge. I mean, it just has this incredibly long, you know, life history, and it's rare, you know, and it's not something that you catch a lot of in the UK. I've only ever seen it once. So up to that point, the goat was my favorite catch. In the book, I then write about how I just dream of one day opening the moth trap and seeing the skull mark on the back of a death's head hawk moth looking back at me. And then last October, I was trapping on Blakeney Point. I take a field course out there, and I opened up the moth trap, and there was the skull mark on the back of a death's head hawk moth looking up. And I sort of lifted up the trap, put the lid back on, and my colleague, you know, a couple of colleagues were there, and they're like looking at my face. It's like, what is it? What is it? It's like death's head hawk moth. And he's like, oh my God, we're going to need a bigger pot. You know, so I ran into the accommodation and came back with a beer glass to put this thing in, because it's so, and it's just, I mean, I've got a picture of it on my phone, but it's, yeah, just, you know, it's about this big. It's rare in the UK. It's a migrant, so maybe that had come from the continent. It's stunningly beautiful. If you poke it, it squeaks. So yeah, it's just incredible. So it's a toss up between those two, but you know, the joy of moth trapping is, you know, every time you open a box, sorry to be Forrest Gump, you never know what you're going to get, you know, and that's part of the magic of it. And sometimes, you know, something that's this big can be just incredibly exciting. There's a species of moth that was actually described from specimens caught on Hampstead Heath, which is about sort of half a mile from where I live, a species I catch. And it's like, wow, this species was described just there. And it's, you know, looks like nothing, but you know, every time I catch one of those, it's just like the excitement of this is my local species.
Great, thank you. And thank you for the talk. It was really interesting.
Thank you.
There are more questions?
Yeah, I'll pitch in one. Last week we had Emma Maris, the writer, as a speaker here, and she was she takes it. Should say quite a laissez-faire approach to invasion, so at least a non-nativeness as well. And so, how much of this turnover in moths, you know, is partially, as the point you talked about, is climate change? How much are it problematic moths coming in, or how much is it simply new things coming in?
Yeah, I mean, so you know, for context, so we've lost since 1900. I think we've lost about 51 species of moth from the UK fauna. So things like the stout dart. We've gained 128 species, so we've, you know, great species richness is going up. Some of that is things spreading in from the continent, but there's quite a few species that are aliens. And then the question is, you know, is this a bad thing or not? So in Camden, I catch light brown apple moth. It's an Australian species. I catch ruddy streak. It's a New Zealand species. The little things, do they really have much of an impact? I don't know. Then I used to catch oak processionary moths. I think they've done some control measures on Hampstead Heath, which means I don't, but this is a bigger species that's been brought in on oaks, and the caterpillars have these urticating hairs that can cause respiratory problems. Is that an issue? It's not a huge one. Box tree moth, you know, if you've got a box hedge, you probably don't want box tree moth. It's an East Asian species that's been brought in with plants moved for box hedging. Yeah, if you've got a box hedge, it'll eat your box hedge, so maybe grow something else. But you know, we've got Box Hill, we've got native box trees, and it in Germany, where it's got into the native box forest, it's had a big impact there. So there is the potential, there's always the potential. But I think, as with any group of aliens, what you tend to find is that, yeah, most of them have pretty minor impacts, but then some of them have major impacts, and often you don't know which ones it's going to be. So the more you put in, just the more tickets you're buying in the lottery for damage.
Thanks.
So at the risk of sounding indelicate, where do you stand on genital inspection? Perhaps you should explain.
Yeah. I assume we're talking about in moths. Yeah, so for those of you that don't know, there are some species that you can't separate just by looking at them. So what you have to do is you have to dissect out the genitalia. So I didn't really talk about this, but we've got about 2,500 species of moth in the UK, and we informally divide them into micro moths and macro moths. So as you might imagine, the macro moths are the big ones and the micro moths are the small ones. Although the box tree moth is actually a micro moth, and the goat moth is also really a micro moth, but it's kind of an honorary macro. So it's kind of an informal distinction. And the reason we do that really is most of the macro moths we can actually identify just by looking at them. So there's one or two that you have to look internally. But for the micro moths, then lots of them, you can only actually identify them if you dissolve away the bodies and you look at the genitals that are left. So I say in the book, my hobby has not yet got me to the point where I'm willing to kill moths just to identify them. As I said just now, sometimes you write things in the book and then things have changed over time. So I'm not quite there yet, but I did spend a very interesting day with Colin Plant, who's the moth recorder for Middlesex and Hertfordshire, learning how to do genital dissection and staining for moth identification. And I now have a little tube of moths at UCL where we've actually sort of started to set up the equipment to actually do some of that. So I'm not sort of into wholesale destruction of things just to do that, but there's one or two where it would kind of be interesting to know which species I've got. And so I'm afraid I'm sliding down that slippery slope into dissolving away the bodies of moths and looking at what's left.
What about you then?
No, there are certain lines I won't cross. So.
Can I just say that? I mean, Colin Plant was amazing. I mean, if you don't know him, he's the kind of person where, when you see on the news somebody saying, oh, I never have thought that he'd be the kind of person to have, got 15 bodies buried under his patio. Colin Plant is the sort of person where it's like, yeah, he would absolutely be the sort of person that would have 15 bodies buried under his patio. But I assume that the smell in his house is just the fact that he spends all his time dissolving the bodies of moths to dissect out the genitals.
Different one, and about writing the book. Clearly, you're a person with a busy day job. So, as also somebody who's sort of struggled in terms of working on writing a popular science book, what was your strategy? How did you manage to squeeze in writing this creative book while doing your day job?
Yeah, so I think lockdowns helped. So, like the initial work on the introduction and the summary, that was kind of, I guess, at the end of that first 2020 lockdown. So, if people can't see what you're doing, that's a good thing. Also, that first lockdown, it was great for clearing stuff off my desk. So getting papers finished that, had been in process, but it was really bad for starting new things. So essentially the one new thing I did start then was writing this book. And then that second lockdown in the start of 2021, that horrible winter lockdown, essentially I was in the flat in Camden. It was horrible, not worth going outside. So I would get up in the morning, I'd have breakfast, I'd go up into the attic and I would write until lunchtime. And a few months of that sort of really broke the back of it. And then I was able to, in the afternoons, I was able to do the rest of my day job and sort of keep my people at work happy. But I will say that once Claire Conrad said, why don't you write about the moth trap? Basically the first 4 chapters were just there in my head. It's stuff I'd thought about writing before, but had never seen how to make it work. And so that first, 40% of the book wrote itself quite quickly. And then I was able to just carry on that process through the rest of the 15 months or so it took to actually sort of write the whole thing. But yeah, as usual with any piece of work, there was a lot of pleasure in that. And then, 80% pleasure and 20% pain is generally how it goes.
Mhm.
Yeah. Yeah.
Great, well, congratulations.
Yeah.
I think I'm looking forward to reading it as well. It sounds it's very inspirational as a talk, as a presentation to that as well. So I hope it does really well.
Well, thank you. I mean, you know, there's always bits that you think, oh, I wish I'd done that differently, but I think actually I'm quite happy, which is an unusual thing for academics to say, I think. But, yeah.
Thank you. And the book is available just down the hallway for signing and purchase. And also the drinks reception if you want to talk more informally. So just go down here to the end. So thank you very much, Tim, and good luck.
Thanks, Thank you.